Hello everybody, welcome into another lesson. So today we are going to talk about solving systems of equations in two variables. And we're going to start the two lessons on doing it algebraically. Now there are two ways of solving systems of equations algebraically. The first one, which we're going to do today, involves substitution. The next lesson solving algebraically will be by the method of elimination, but today we're just going to do substitution. Substitution is actually fairly easy. So here you have the system 2x plus 3y equals 5, and then x minus 5y equals 9. The idea by solving the system of equations is to figure out where do these two lines intersect. Well, you can substitute one of the values of the variable in for the other in one of the equations. Well, if we look at x minus 5y equals 9, doesn't it almost look like we could put x by itself on the one side and set it equal to 5y plus 9? We can actually do that. X equals 5y plus 9, and then you can go ahead and take that 5y plus 9, where the x is in the first equation, that 2x plus 3y equals 5. So take 2 times that value of x, which is 5y plus 9, plus your 3y, set that equal to 5. So you've brought this to an equation of one variable. We just got to solve for y to start with. So let's distribute this here. You would end up getting 10y plus 18 plus 3y equals 5. If we simplify this, you would get 13y equals negative 13, which would just give you a y value of negative 1. So we found the y coordinate of the solution. Now in order to solve for x, all we got to do is put that y value of negative 1 into the substitution equation. So x would equal 5 times that negative 1 plus 9, which would end up giving you negative 5 plus 9, which would give you an x value of 4. So you get the x value of 4, y negative 1, so you get the ordered pair 4, negative 1 to be the solution to this system of equations. That is where these two lines intersect, is at the point 4, negative 1. And if you're unsure, put that point into your equations and you should get a true statement on both sides. I got more. Alright, what if we had something like negative 2x plus y is equal to 6, then we have 4x minus 2y equals 5. So we have the system here where negative 2x plus y equals 6, and then 4x minus 2y equals 5. We're going to solve by substitution. If you look, you have a coefficient of 1 on the y term. You always want to look to see if you have a coefficient of 1 on any of the variables. If you do, it's a lot easier to substitute. If you don't, you have to factor this in such a way to make one of the variables have a coefficient of positive 1, but it's already set for us. The y in the first equation has a coefficient of 1, so we can set y equal to 2x plus 6. Take that first equation, get y by itself, you would get y equals 2x plus 6. So now in the second equation, you can take that y and substitute that in. So that's going to look a lot like 4x minus 2 times that y value of 2x plus 6 equals 5. Alright, so let's go ahead and do this here. You would end up getting 4x minus 4x minus 12 equal to 5. Well, if you simplify this, all you're going to have is that negative 12 equals 5. Well, negative 12 certainly doesn't equal 5. Okay, so what does that mean? When you get a false statement and the left side equals the right side, that means there's no solution. There is no solution to this system of equations. And what does no solution mean graphically? Graphically, if you were to try to graph these two lines, you would end up getting two parallel lines. Whenever there's no solution, that means the two lines are parallel to each other. As we know, parallel lines run without ever intersecting each other. That's what parallel lines are. So whenever you get a false statement with no solution, that means you're going to have two parallel lines. They'll never intersect. All right. So let's see. We have negative x plus 2y is equal to positive 3. Then we have 4x minus 5y equals negative 3. Alright, so we have this system here. We have negative x plus 2y equals 3, and then 4x minus 5y equals negative 3. Well, I think it's safe to say this x is to the first power. I mean, well, of course it is. This x has a coefficient of negative 1, but if we just move the x over to the right-hand side and subtract the 3 from the right-hand side, what you have is x would equal 2y minus 3. And you have something now that you can substitute into the second equation for x. So you can substitute 2y minus 3 for x in the second equation, which is going to look a lot like 4 times that 2y minus 3 minus the 5y would equal negative 3. This becomes 8y minus 12 minus 5y equals negative 3, which would end up giving you 3y equals 9, which would give you the y coordinate for your point of intersection being 3. So we did find our y value. Now we need to find our x value, and we can put the y value into our equation of substitution to solve for the x value. So x would equal 2 times that y value of 3 minus 3, which means x is going to equal 6 minus 3, which means x would equal 3. So x and y both equal 3. That means these two lines both intersect at the point 3, 3. So the ordered pair 3, 3 is where these two lines would in fact intersect. All right. We have 5x plus 3y equals 4. And then 5x plus y equals 16. So we have these two equations here that we need to find the point of intersection for, these two lines. Well, you have a coefficient of 1 on the y in the second equation, so we can get y by itself. That would make y equal to negative 5x plus 16. We now have something we can substitute into the first equation since we've done that. We can substitute that negative 5x plus 16 in for where we see y. So let's go ahead and do just that. You would end up taking, in the first equation, 5x plus 3 times that negative 5x plus 16. Set that all equal to 4. This would turn into 5x minus 15x plus 18 would have to equal 4. Right, so then 5x minus 15x, that's negative 10x, which would end up equal 4 minus 18 is going to end up be 4 plus 8, 4 minus 18 would be negative 14. Well, you would get an x value of 7/5. So we found the x coordinate to be 7/5. Now we could solve for y by simply putting the x value of 7/5 in for x. So y would equal negative 5 times that x value of 7/5, all that plus 16. Which y would be equal to negative 7 plus 16, which would give you a y value of 9. So the coordinate for the point of intersection of these two lines, the ordered pair, would be 7/5 and then 9. So these two lines intersect at the ordered pair 7/5, 9. And it is normal to get fractional answers. You will have that sometimes. Next, okay, 4x plus 6y equals 15. Negative x plus 2y equals 5. So we have the system here, 4x plus 6y equals 15, and negative x plus 2y equals 5. Let's use substitution to find the point of intersection of these two lines. Well, it looks like we have a negative 1 on the x, so if we just move x over to the right-hand side and subtract 5 from the right-hand side, you can get x by itself and use that for substitution. You would end up getting x equals 2y minus 5. Now you have something that you can substitute into the very first equation. We can take that 2y minus 5 and substitute that in for x into our first equation. So take 4 times that 2y minus 5 plus 6y, set that all equal to 15. Well, this would end up giving you 8y minus 20 plus 6y would end up equaling 15. So that would give you 14y would equal 35. Well, good news is they both have a common factor of 7. So y would equal 5/2. So you get a y value of 5/2. Now we just need to go ahead and solve for x by putting the y value in for that equation. So x would equal 2 times that y value of 5/2, all that minus 5, which would mean x equals 5 minus 5, which would give you an x value of 0. So the ordered pair that's the intersection of these two lines will be located at the point 0, 5/2. That is the point of intersection, would be at 0, 5/2. I got about 7 more, then we're done. All right, let's see. 3x minus y equals 4. And then 5x plus 3y equals 9. So we have the system of 3x minus y equals 4 and 5x plus 3y equals 9. Let's use substitution to solve this system of equations to find the point of intersection. Well, in the first one, we have a -1 coefficient on the y. If we just move the y to the right-hand side and subtract 4 from the right-hand side, we can get y by itself. That would make y equal to 3x minus 4. So now, in the second equation, we can take that 3x minus 4 and substitute that in for y. So let's go ahead and do that. You would end up with 5x plus 3 times the quantity of 3x minus 4, which would all equal 9. Well, this would give you 5x plus 9x minus 12 equals 9, which would end up giving you 14x equals 21, which means x would be equal to 3/2. So there's the x-coordinate of the ordered pair for the point of intersection. Now we can solve for y just by putting 3/2 in for x. So y is going to equal 3 times 3/2 minus 4, which would give you 9/2 minus 8/2, since that's 4, which means y is going to have the coordinate of 1/2. So the ordered pair that's the point of intersection would be at 3/2, 1/2. That would be the solution to this system of equations. It would be 3/2, 1/2. Six more. Half of x plus y equals 9. 7x plus 4y equals 24. So we have this system of equations here where you have half of x plus y equals 9, then 7x plus 4y equals 24. So let's use substitution to solve. We have a +1 coefficient on y, so if we get the y by itself, we can substitute in the y in the second equation. That would make y equal to -1/2 of x plus 9. Now we can substitute the -1/2 x plus 9 in for the y in the second equation. So let's go ahead and do that. You would end up getting 7x plus 4 times the quantity of -1/2 x plus 9. Set all that equal to 24, which would give you 7x minus 2x plus 36 equals 24, which would give you 5x equals -12, which would end up giving you the x-coordinate being -12/5. Now we can solve for y by putting the x value in here. So y would equal -1/2 times -12/5 plus 9, which would have to mean that y would equal 6/5 plus 45/5, because that's 9, which would mean you would get a y-coordinate of 51/5. So the solution to this system of equations, the ordered pair, is going to be -12/5, then 51/5. And yes, you will get answers like this sometimes. So the ordered pair is -12/5, 51/5, 51/5. -12/5, 51/5. That's how I should say it. Got 5 more and then we are done. let's see. Okay, so we have the system here of negative 3x plus y equals 2, 8x minus 15y equals 7. So we have a positive 1 on the y, so we can get y by itself and use that for substitution. That would have to mean that y would equal 3x plus 2. Now in your second equation, you can take wherever you see the y and put in 3x plus 2 for that value. So what you would get is 8x minus 15 times 3x plus 2 would equal 7. This would give you 8x minus 45x minus 30 equals 7, which would give you that negative 37x would equal positive 37, therefore giving you an x value of negative 1. So we found the x value of negative 1. Now we can find the y value by substituting the x in the substitution equation. So y would equal 3 times that x value of negative 1 plus 2, which means y equals negative 3 plus 2, which would give you a y value of negative 1. So the ordered pair that's the solution to this system would be negative 1, negative 1. That would be your solution, would be negative 1, negative 1. 4 more. All right, what do we got here? We got 5x plus 6y is equal to negative 45. Then we have x minus 1/2 y is equal to 8. All right, so we need to solve this system here. We have 5x plus 6y equals negative 45, and then x minus 1/2 y equals 8. Well, let's use substitution to solve the system. We have a positive 1 coefficient on the x, so let's get the x by itself. If we do that, you would get x equals 1/2 y plus 8. Now you got something you can work with to put into the first equation. You can actually put in the 1/2 y plus 8 where you see x in the first equation. So let's go ahead and do that. You would take 5 times the quantity of 1/2 y plus 8, all that plus 6y, set all that equal to negative 45, which would end up giving you 5/2 y plus 40 plus 6y equals negative 45. So let's see, you would end up getting 5/2 y plus 12/2 y, because that's 6, would equal negative 85. Which would end up giving you 17/2 y equals negative 85, which therefore means that 17y would equal negative 170, which would give you a y value of negative 10. So y is equal to negative 10. We found the y coordinate for the solution. Now let's put in the negative 10 in our substitution equation for y. We'll be able to solve for x. So x equals 1/2 of negative 10 plus 8, which would end up giving you negative 5 plus 8, means you get an x coordinate of positive 3. So the ordered pair, that's the solution, would be at 3, negative 10. That is exactly where these two lines intersect, is going to be at the point 3, -10. Should have 3 more, then we're done. All right. We have -x minus 4y equals -3. We have 2x plus y equals 15. So we're going to solve this system of equations here. We have 2 options for substitution. Take your pick. I'm going to say that we work with the second equation because you have a positive 1 coefficient on the y. So if we use that for our substitution and get y by itself, that would give you that y equals the negative of 2x plus 15. So we used our second equation to turn this into substitution. Now, where we see y in the first equation, we need to put in that negative 2x plus 15. So this is going to look a lot like -x minus 4 times the quantity of -2x plus 15, all that equal to -3, which would give you -x plus 8x minus 60 equals -3, which would give you that 7x equals 57. This is looking pretty hideous. So you would end up getting x equals 57/7, which unfortunately there's just no way to reduce that. But let's solve for y by putting in that x value. So y would equal -2 times 57/7 plus 15, which would have to mean it's -114/7. All right, now what is 15 in terms of 7? That'd be 105/7. Which would end up giving you that y equals -9/7. So yes, this one was pretty hideous, but you will get that sometimes. So the ordered pair that's the point of intersection would be 57/7 -9/7. That is the ordered pair that is the point of intersection of these two lines, 57/7 -9/7. Should be 2 more. 2 more, then we're done for this lesson. Okay. We have x plus 2y equals 2. Then we're given that 7x minus 3y is equal to -20. So here's the new system of equations. We have x plus 2y equals 2, 7x minus 3y equals -20. Since we're using substitution, I think it's obvious we want to go with the first equation because you have a positive 1 coefficient on the x, so you can get that x by itself to form a substitution. If you did that, you would get x equals -2y plus 2. Now we can take wherever you see this for x in the second equation, substitute that -2y plus 2 in for the x. So here's what it's going to look like. 7 times the negative of 2y plus 2 minus 3y would all equal -20, which would give you -14y plus 14 minus 3y would equal -20, which would give you -17y equals negative 34, which would give you a y value of positive 2. So you end up getting that y equals 2. Now we can easily solve for x by putting that y value of 2 into the substitution equation. So x would equal the negative of 2 times that y value of 2 plus 2, which means x equals negative 4 plus 2, which would give you an x value of negative 2. So the ordered pair that's going to be the solution is going to be negative 2, 2. That's your ordered pair that's the solution, is at negative 2, 2. That's where those two lines would intersect. And one more, then we're done. Alright, last one. 3x minus y equals 4. Negative 9x plus 3y would equal negative 12. So we need to solve this system here. We have 3x minus y equals 4. Negative 9x plus 3y equals negative 12. Again, we're doing the substitution method. You have a negative 1 coefficient on the y, so if you move the y over to the right and subtract 4 from the right-hand side, you can get y by itself. That would give you y equals 3x minus 4. Now you have your equation of substitution. You can easily put this in where you see y in the second equation. That's going to end up giving you negative 9x plus 3 times the quantity of 3x minus 4 would equal negative 12. So this would give you negative 9x plus 9x minus 12 equals negative 12, which would become 0 equals 0. Well, 0 certainly does equal 0, that's true, but that's all you have is a true statement. You don't have any points for where they intersect. Whenever you just get a true statement without any values, like you have 0 equals 0, 1 equals 1, 100 equals 100, negative 500 equals negative 500, what have you. If the right side just equals the left-hand side, that means they're the same line, literally. And it has infinitely many solutions. So any points on those lines, so you have infinitely many solutions. What that means when you have infinitely many solutions is that these are both the exact same line. They're one and the same. One's a multiple of the other. That's all it is. They're the same line whenever you have infinitely many solutions. So that's it for the substitution method. The next lesson we will do these by elimination method. So I hope everybody has a great night. Take care.